To find the mean of random variable x plus random variable y, we find the individual means and add them together. One might suspect that we could do the same for the standard deviation of x plus y, but this is not the case. Standard deviations are found by first calculating variance and then taking the square roots. Therefore, we must find the variance of both variables, add the variances together, and then take the square root of the sum of the variances to find standard deviation. We can better comprehend by using the x and y variables from Video A, their joint distribution tree diagram, and the golden calculator. Here are the means, standard deviations, and variances of the random variables x and y. Here's the joint distribution of x plus y from the tree diagram. Here's the joint distribution of the calculator and the one-var stats. Using one-var stats for mean and standard deviation, we get 7.7 and 4.4057 respectively. As mentioned, we can add the mean of x and mean of y to get 7.7, but adding the standard deviations of x and y does not yield the standard deviation of the joint distribution. But notice that the variance of the joint distribution is 4.057 squared, which is 19.41. And by golly, this is the sum of the variance of x and the variance of y. So remember, to find the standard deviation of a joint distribution, add the variances and then take the square root. Another important feature, though, is that variables must be independent to trust the standard deviation can be found this way. But what, you might ask, would be the standard deviation if you subtracted the random variables like y minus x? Well, that'd be a dandy question. Here's the tree diagram for the difference. The outcomes are the y values minus the x values. Look at the golden calculator. I put this probability distribution in lists 3 and 4. Let's do one-var stats and see what happens. The mean is 1.3. Yep, this is the difference of the mean of y and mean of x. But look at the standard deviation. It's the same as when we added the values. But this makes sense. Measures of spread describe spread. And the y minus x values of -2, 3, 8, -5, 0, and 5 all differ by the same amounts as x plus y, which is y plus x, which is 2, 7, 12, 5, 10, and 15. Means describe center, average. It very much matters whether we're adding or subtracting. But variance and standard deviation describe spread contributed by each value. This spread is present whether adding or subtracting. So remember, always find standard deviation by taking the square root of the sum of the variances, and only trust this if the random variables are independent.